Hi everyone, I'm Maxime Mularz. I'm from France. I'm the founder of Hostabee, and I'm here to talk about the management of water for sport field. So, okay, just a few words about Hostabee. We started with monitoring bees with IoT, LoRaWAN, and EI with temperature and humidity. That's the beginning of Hostabee. That's why it's called Hostabee. But something's happened and changed the game. So let's talk about the agenda of the presentation. So I will talk about the pivot to smart watering, why we change our business model. Oh, too quickly. Okay, what about irrigation system? How we can manage the irrigation for feed. And after that, we talk about humidity sensor and the result of the use case. And an important point is to be expert. We are really familiar with IT, with technology, but for the field, we have to improve our knowledge. And of course, a conclusion of our project. So, the pandemic, COVID pandemic was hard, and for beekeepers, it's for hobbyists. It's not really a business. So, a lot of beekeepers stopped using sensor. It's not our first idea, and we have to. Okay, if we stay with bees, our company will stop. So we had a chance, an opportunity with a call for tender for a city of Saint-Quentin to develop a smart solution to reduce the waste of water, and we had to use freeware platform. Maybe you're familiar with this. I will explain a few words about that. So that's what the rules. So first question I've got in my mind, how much water does a sport field need? That's someone have the answer? Do you know? No. Yes, that's it. 30,000 liters per cycle. Okay, it's approximately the water for one person for 6 months in France. It's really, really important. So that was the number in my mind. So I had to reduce this quantity of water. So let's go to the work. So the first stage was to use the freeware platform. A few words about freeware. Freeware developed some tools for smart cities. Develop a context broker. With this one, we can store the data of our sensors, and you have IoT agents to get the data of your sensors. So now, talk about watering controller. So this is a sprinkler. Do you have 24 sprinklers on the field? Okay, it's the average. And each sprinkler is controlled by a station. Okay, this is the field. You have the station and you have sprinkler. Okay, a station control a sprinkler or more sprinklers. So you have to control this, and how to do this? Up. So there was already a solution to manage the irrigation system. Weinberg is the most famous company to develop irrigation system. So we don't have to change this. No, it's good because they are already reliable. Don't have to change this solution. What we noticed is that Weinberg had a web application. So if you have a web application, maybe you have an API. So we found the API of Weinberg, and with this, we add the stack of watering controller. We do nothing except to use an API. So we had our controller. Next step is to know the humidity of the sensor, the soil moisture. So we have two solutions. The first one, we have on the wheel, create another device to produce them. We did this with bees. We developed this for 3 years. So we don't have time. It's call of tender. So thanks to Orange, which introduced with Sensoterra, just to notice, we are in 2020. Okay, there are not a lot of solutions using humidity sensor. So this sensor, you have to just put this in the field. But just imagine soccer player with this spot. Okay. So, okay, just sample. Instead of install this horizontally, just vertically, sorry, just do this horizontally. That's what we did. We installed the sensor horizontally, and the most important, I can use it, is to have the sensor in the roots. Okay, to know exactly the humidity just there. It doesn't make sense under the roots. So we have our sensor up, next up. Don't forget to notice, to mark the place of your sensor, because you won't retrieve them. Okay, it's my experience. So that's what we have now. We have the controller, and we have humidity sensor. Okay, and with this, we had 2 months to produce the response of call of tender. And okay, the controller, the humidity sensor. Okay, now we need a user app. Just very easy sample app. You have the field, and each square with humidity weight, it's the position of a sensor. And the sensor position really depends of the sun exposition and depend of the soil quality. Okay, that's the point that we have to adapt. So sorry, it's in French because our device, our solution is only in France, but translate is not a problem. So this is the humidity, and now you have the recommendation. Okay, you have the station, as I told you, and you have sprinkler. And just to know, to be clear, yeah, that's the quantity for each sprinkler. It's approximately 200 liters per minute. Okay, it's awesome. So all of this produce the water controller, the humidity sensor, the platform, and the user app with planification, quantity of water, and the modelization. So that was really perfect, and we save the water of the city, and we save the world with 30% decrease in consumption the first year. But the last year. Okay, so as I told you, you have to be an expert. Okay, we was engineer only focused on IoT, LP1, everything like this. So we missed a lot of things. That's why I told I had this part. You need to be expert. 2 things, just about your fields. You have to know the kind of field you have. Okay, if there is clay, something or sand, you have. Yeah, it's really important to set up the sensor. And the other point is this one. We call this reservoir utile, maybe in English, useful reservoir. It is the quantity of water that your soil can keep per litre per square meter. Okay? Donc my soil can keep 11 liters per square meter. Okay. With this, we can have a link between the humidity and the reservoir, and the goal was to always have 2 days of reservoir, okay, to avoid problem of dry. And next, so the other point, it's the weather. Okay, we didn't catch the weather, so we had the weather, and we use open weather map to solve this, and we only use the temperature and the rainfall. That's it. It's enough. And the rule: if the temperature is more than 24 degrees, okay, you have to water. And the other problem is how to forecast the rainfall. It's easy during the autumn, during the winter, but during the summer, it's very difficult. So instead of use algorithm, a lot of solution, we use the sensor of rainfall with a sponge inside, and when the sponge is too wet, the programmer, the controller is off. So it's very simple, and it works. And the other problem that we had, it's the connectivity. At this stage, we have 10 fields equipped with the programmer and the sensor. And we have only on one place, we had to add a gateway, because when you install the device horizontally with soil, okay, you reduce the quality of your signal. So as I told you, we have 10 fields equipped in France. So our goal is to extend this solution. And the next step is to improve the model. So maybe we have some use cases that we don't know yet. For example, if you are in northern France or in the south of France, it doesn't have maybe the same models. But the idea is there. All the devices are there. The programmer is there. Everything is there to develop this kind of solution easily. Thank you for your time. If you have some questions. No question? Yes. Sorry?
Yeah. A question. How do the sensors handle aeration, these spikes from machines that goes down in the fields and so on?
So your idea is using
yeah, they usually use machinery that goes down, that puts metal spikes in the grass to move air into the soil and into the roots. So how do they survive these kind of machines? Do you have had problems with it?
With the sensor?
Yes.
Yes, we have no problem with the sensors. They have a lot, really big, long autonomy. And that's why we use LoRaWAN, of course, because it's really it's cheap and very low consumption. And maybe we have a device, it's maybe four years already in place. It may be 20% left. Okay. Maybe, of course, you have to change this. You cannot change the battery yourself, because it's really aggressive environment. So, but we have to change the battery every. It depends on the position of the sensor and the antenna. yes, it's the change the duration of life of your sensor. Do you have another question? Yeah, yes.
So, as I understand it, you focused on the, I would say, public areas. Have you tried to do this on agricultural fields with big farms, stuff like that?
No.
No. Okay.
No, because it's not our business. We have really focused for cities. We have already 3 cities,
Okay.
and it's difficult to extend our market. Just do it good, and maybe after that we can change, but step by step. There are a lot of competitors already in this kind of solution.
Okay. Great, thanks.
You're welcome.
Yeah. Next question. How many sensors do you need for a field?
It really depends of the station you have. We have some field with only 8 stations, so and the field is really the same. Maybe 2 sensors are enough. It really depends of the number of the station do you need, because it's not the same calculation of preconization. Yes, it really depends of the station. I can tell more. Thanks. Okay. Thank you so much.